to talk a little bit about 4.4 here. Now, just so you know, I did not make one of these videos for 4.3 because there was nothing in the 4.3 reading guide that wasn't straight out of the book. There were no essential questions or anything for that from the new course guide. Okay, but there's a couple of things that I do want to go over on this reading guide. First of all, I don't know, most likely you guys haven't had really a chance to go through all of this yet, but this is about redox, oxidation reduction reactions, okay? And basically what you need to know about redox is, well, there's lots of things, but the big idea here is redox is a reaction that happens anytime there's a transfer of electrons from one atom to another atom, okay? That's what redox is, oxidation reduction, all right? And so we'll get to this in a second with number 15, but look at number 9 for a second. Because for those of you who had me last year, I need to undo one of my lies real quick. Yeah.
Little white lies.
Even little white lies what? Yeah, that's true. Yeah, especially if there's a lot of them. All right. So number 9, it says the activity series for metals is on table 4.5 on page 141. We learned about the activity series last year. Do you guys remember the activity series and my analogy of the big guy on the beach kicking sand in the little guy's face and then taking his girl? Remember that? Okay. Yeah, that's not really what happens in a redox single replacement reaction. Okay. Really, single replacement doesn't even necessarily happen. Because what really happens, and you're just not ready for this when I teach this in Honors Chem, but what really happens is something is stealing electrons from something else. That's really what's going on here. All right, so let's look at an example. So the reaction of lithium metal with calcium nitrate. Okay, so the first thing it says to do is write the molecular equation for that reaction and then the net ionic equation for the reaction. So lithium metal with calcium nitrate, what's the molecular equation for that one? Li first, right? And then you can put solid here if you want to. States of matter, to my knowledge, still do not matter on the AP exam. I'll let you know if that changes. So lithium plus calcium nitrate. What's calcium nitrate? CaNO3. Okay? And last year we looked at boy, I'm not going to have enough room for this. We looked at the activity series last year to decide, can lithium replace calcium? In other words, can it kick the calcium out and pair up with the nitrate, right? You guys remember that? So, and if you look at an activity series, it can, right? It's higher up on the activity series. So then you end up with lithium nitrate plus Ca2 plus. Whoops, I messed up. CaNO3 2, sorry. So then there needs to be a 2 here, and there needs to be a 2 in front of the Li. Okay? All right? Everybody okay with that? Now, that's the molecular equation for this one, right? No. What am I doing? Why does this have to be on video? It's just calcium metal. Yeah, I apologize. Okay, there we go. So that's the molecular equation for this, all right? Now we need to write the net ionic equation for this one. The two things that I didn't label are actually, they're just aqueous, all right? So that really kind of gives an incomplete picture of what's actually happening in this reaction, okay? If we want a real picture, then maybe we write the overall ionic equation first, and we'll split up the Ca2 plus and the 2 nitrates that come from this, right? Sorry. Yields. And then you end up with 2 Li plus on this side, plus 2 NO3 minus, plus solid calcium. All right, so now you might be able to see it. What's the spectator here? The nitrate is the only thing that doesn't change at all, right? Does everybody see that? Okay, so let's get rid of the spectator. Now look at your net ionic reaction here. There is no anion being stolen from anything here. There's just a change in charge. Okay, does everybody see that? Well, okay, so you got two nitrates on this side, two nitrates on this side. It didn't do anything in the chemical reaction, right? So remember, in a net ionic equation, we get rid of the spectators. This is lithium, and this is lithium 1 plus. I would argue that those two things are different, right? Does that make sense? And then same thing here, calcium 2 plus and calcium are different, right? How are they different? Well, okay, but the charges are different, but why are the charges different? How does something develop a charge? It's something having to do with the electrons, right? Either they gain extra electrons and become negative, or they lose electrons and become positive, right? So these are not the same, but the nitrate is the same. It's NO3 minus here, it's NO3 minus over here. Nothing changes with the nitrate. Does that make sense? Okay. So that's what a redox reaction is. It's actually a transfer of electrons. Now, looking at the charges here, can you tell where the electrons are going? It's a little tricky, but you should be able to see it. Yeah, it's a little tricky. You have to think sort of backwards here, right? But the electrons are going to the calcium. Does everybody see that? Because calcium starts out positive here, and then it becomes neutral, so it must be gaining electrons, right? It must be gaining negative charges. Okay? So the electrons are actually going to the calcium. And then lithium is losing electrons. All right? So last year, based on the activity series, we would have called lithium the strong one, the one that was stealing the girl, right? This is kind of like a bad lie, because now it's going to confuse you this year, and I apologize for that. All right, I maybe need to rethink my analogy on this one, because what's really happening is the calcium is stealing electrons from the lithium, right? That's what's really happening here. The calcium's coming along and saying, hey, give me your electrons, right? Then the calcium becomes neutral. The lithium, yeah, it really is more of a mugging than a cheater's sort of thing, right? Because the nitrate's just there watching all this go down, you know? I mean, the nitrate could be a good Samaritan and try to stop this, but no, just sits there. Just sits there and lets it happen, right? So that's really what's going on here. Does that make sense? This is a redox reaction because there's a transfer of electrons happening, and that's what we call redox, oxidation reduction, okay? Now, oxidation is when something loses electrons. So what's getting oxidized here? Say it again. I heard some of you say it, but very quietly and mumbly. Lithium's getting oxidized, right? Because it's losing electrons. And then the things that gain electrons are getting reduced. So that would be the calcium, right? Calcium's getting reduced. Anytime in a reaction that you have an oxidation, you also have a reduction. One does not happen without the other. Electrons do not just leave and go nowhere. Okay? They always go from one thing to another thing. Otherwise, they don't go. Does that make sense? Okay? So that's oxidation reduction. All right, now I got a handy little, on the next page, number 15, nice little acronym that will help you with this. Leo goes grr. All right? You're going to say this to yourself a lot, this unit, I promise. Leo goes grr. All right? Lose electrons, oxidation, Leo. Goes grr, gain electrons, reduction, grr. All right? And probably at some point I will growl at you to remind you whether something's getting oxidized or reduced. I'll just say grr, and you'll know what I mean, okay? All right, so Leo goes Gur. You need to remember that because this will help you to decide whether something is getting oxidized or reduced. All right? Does that make sense? Yes, ma'am. Oh, yeah. Sorry. Oh, yeah. 4.3 is acids and bases, and there's not really a lot to that one. So this is the one that's got a lot of the new stuff in it. Now I need to find one for myself. All right. So looking at number 15, I think it's number 15, yeah. This tells you to look through a couple of the new course description things. Not even going to try to read that. All right, so I have bad eyes. All right. So, by the way, if I ever am down the hallway from you and I don't acknowledge you, that's because I can't see you. So don't feel bad. All right. I'll know as soon as I get closer to you. Oh, that's who that is. So. Huh? Not very well. All right. Anyway, so enduring understanding 3B is what number 15 sort of directs you to. Okay. So I want you to pay attention to this. Really? All right, so I want you to pay attention to Enduring Understanding 3B because I think maybe now that we have talked about this a little bit, you can understand why when they include classes of chemical reactions, notice what's not there. They have synthesis, which is combination, right? They have decomposition. What's missing from this list that we learned last year? Single replacement and double replacement, because with precipitation, I told you that doesn't really exist, right? Wife swap doesn't really happen. These things are already ions in solution, and they really just kind of combine and precipitate, right? So that's why they don't include it as a category here. Single replacement, I just told you, doesn't really exist because what's really happening is a redox reaction where electrons get transferred from one thing to another. So there it is. There's your single replacement reactions under the oxidation reduction heading, okay? So really, these four classes of reactions are the ones that we're going to focus on for most of the year. All right? I would say all of the year, actually, now, because they took nuclear out of the curriculum. Sorry.
What?
I know, I like nuclear too, but we don't really have time to cover it this year. So anyway, all right, so 3B3, need to go down to that. And that's where it starts talking about oxidation reduction. The species that loses electrons is oxidized, and the species that gains electrons is reduced. They could have saved themselves a lot of times by just making this essential knowledge say Leo goes Gur. All right? But I'm not sure everyone would have known what that meant, but you do. Okay? Oh, you know. All right. So 3BA, again, this isn't telling us anything that we didn't already talk about just a minute ago. This is good news for you even though you don't know it. You don't have to worry about reducing agent or oxidizing agent. But that means nothing to you because I never taught you that last year anyway. So, but it's just one extra thing that you really don't have to remember that's actually kind of confusing. So that's good news for you that that is out of the curriculum now. Okay? But you don't know what it means, so don't worry about it. All right. Oxidation numbers, okay? You're going to get some practice from the book on oxidation numbers if you go through the reading guide here. You're also going to get some additional practice from me today when I hand out the worksheet, okay? And then what else do we need to talk about? 3C involve a change in energy, 3C1 and 3C1D. Production of heat, light, formation of a gas, formation of a precipitate, and or a color change. Well, that's not really relevant to what we're talking about. It just mentions redox reactions, so I think that's why I put that one in there. And then we already talked about physical versus chemical or ambiguous. So we may talk about that a little bit more. Yeah, I don't really have a lot else to say about that. I'm not sure exactly why I included that one here. Maybe I just didn't know where else to put it. But that's redox. Does that kind of make sense? I mean, that's a very quick overview of redox. You need to read this. Okay? You need to read the book section. This book, I'm telling you, it does a really good job of explaining this stuff. Okay? Basically as good as I did last year, because my notes were straight out of the book from last year, and this book's even better than the book that I used last year. Okay? So just make sure you're keeping up with these. Your quiz on this is going to be on Thursday. All right? So now we'll do some practice on that.